All right, dividing using synthetic division. So last time we looked at using just long division. The nice thing about long division is that you're not really going to forget how to do long division. You've been doing long division since elementary school. So when in doubt, when you're dividing polynomials, if you forget how to do synthetic division, just use long division, okay? But synthetic division is nice because it takes out a lot of that placeholder stuff with the x's and all this kind of business, and it works out really well. Okay, so first of all, they have a worked out example here. So you can also look through these steps. It also very specifically talks about how to do it. Okay, but I'm just going to go ahead and skip down here and work an example for you. So when you do synthetic division, you're going to take the solution to what you're dividing by, and you're going to put it in a little box. So the solution to x minus 2 is just x equals 2. Okay. From there, you take the coefficients of your polynomial and put it all across here. Now, the big thing is you have to be sure that you have everything there. Okay, so in this case, I had an x cubed, an x squared, an x, and a number. They're all there. I can leave it alone. Step 1 is you bring down your leading coefficient, so that's 3. Then you just multiply, so 3 times 2 is 6. You simplify these, so that's a negative 7 and a positive 6. When I combine those, that's a negative 1. I again multiplied. Negative 1 times 2 is a negative 2. When I combine those, that's a positive 7. 7 times 2 is a 14. That equals 0. The last box is always your remainder. So this one has a remainder of 0. And then I just fill in my x's, always starting with 1 degree less than what you had originally. So if this was an x cubed, I'm going to start off with an x squared, an x, and then no x. So this is 3x squared minus x plus 7 is your solution. You would have gotten the same thing if you had done long division. Okay, I'm going to work another one. I'm actually going to work several more. If you watch a couple and you feel like you got it, what you should do is pause the video, go ahead and work them out yourself, and then check it. And then be sure you check out the last example on here because it's different, and if you don't watch it, you're going to get it quite wrong. So again, inside my box goes the solution to this, which is a negative 1. Across the top, my coefficients, 5, 7, negative 1, negative 3. Again, be sure you have them all, x cubed, x squared, x and the number. Bring down the 5. 5 times negative 1, negative 5, that's a 2. 2 times negative 1, negative 2, that's a negative 3. Negative 3 times negative 1, positive 3, that's a remainder of 0. And again, I can just fill in my x's. So notice that this is a lot shorter than what we did last time using long division, a lot simpler. But like I said, it's not something you would naturally, if you forget how to do it, you're not going to come up with it on your own. Okay, next example. And again, if you feel like you got it, work ahead, come back and check it. Be sure you check out example number 7. So in the box, again, my solution, my coefficients go across the top. Again, be sure they're all there. Unfortunately, all of these have all of the coefficients there. There are a couple on your homework that, for example, will only have an x cubed and then the number. If that's the case, you have to fill in zeros for the numbers that aren't there. But again, I can work this out just like the last one. Bring down the number. 2 times negative 3, negative 6. 3 and a negative 6, negative 3. Negative 3 times negative 3, positive 9, negative 1, 3. Also a remainder of 0, which is good. I like remainders of 0. And again, I can just plug back in my x's. I'm going to keep going. This one's a 4 in the box. Again, your solution here, so you do have to change the sign. A lot of people forget to do that too, which is why I say long division's a little bit better because you don't have to worry about that step, and it's easy to forget it. 1 times 4, 4. Negative 8 and 4. Negative 4, negative 4 times 4, negative 16. 19 minus 16 is 3. 3 times 4 is 12. We're going to have a remainder this time. Negative 9 plus 12 is 3. So just like when we did long division, you're still going to fill in your x's. That's x squared, 4x plus 3 plus, and you're going to put your remainder over what you divided by. Looking at the next one, again in the box, negative 5. Coefficients go across the top. They're all there again, so 6 28, negative 7, 9. Bring down the 6. 6 times negative 5, negative 30. 28, negative 30, negative 2. The other thing, people lose track of their negative signs, and if you lose a negative sign, you could get some wild answers here. So be sure you're paying attention to that. 9 minus 15 is a negative 6. Again, I can fill in my coefficients, or my variables. Again, minus 6 over x plus 5. Okay. Same thing with the next one. In the box goes a 2. 1, negative 4. 1, 7, negative 2. Again, this is an x to the 4th. I have the x to the 4th, x to the 3rd, x squared, x, and a number. So we're good to go. Bring down the 1. 1 times 2 is 2. It's a negative 2. It's a negative 4. It's a negative 3. Remainder is 0. That's good news. Now, on this one, we started with an x to the 4th. So whenever I get ready to fill my letters back in, I'm going to start with an x cubed. So that's 1x cubed, 2x squared, 3x plus 1. No remainder. Okay. All right, last one. When you have a number in front, okay, these are the ones you're going to like the least. And this is part of why you also sometimes long division is better, because you don't have to worry with what you're fixed to have to worry with here. When you have that number in front, we can't really divide like that. So what we do is we go through and divide everything by a 3 to make that go away. So that's the very first thing I'm going to do, divide everything by 3, the whole thing by 3, to get rid of that number in front of the x. When you do that, that's a 4x to the 4th, plus 20 over 3, x to the 3rd, minus 24 divided by 3 is 8, x squared, plus 20 over 3, x, plus 35 over 3, divided by x plus 5/3. So in the box, I'm going to put a negative 5/3. Oh man, you love fractions so much. So if you really, really, really hate fractions, this is your opportunity to use long division instead. I know how much you loved it, but fractions are not that difficult, and you really need to be able to work with fractions. And they usually, these problems are set up to work out nicely. For example, when I do 4 times a negative 5/3, remember when you multiply fractions, you multiply the top numbers together and the bottom numbers together. Well, there is no bottom number here. So that's just going to be 4 times negative 5, which is negative 20 over 3. Well, 20 over 3 minus 20 over 3 is a 0. When you do 0 times negative 5/3, that's a 0. That's a negative 8. All right. Negative 8 times negative 5/3, well, again, you're going to do the 8 times the 5. That's 40. Positive 40 over 3. Well, 20 over 3 plus 40 over 3 is going to be a 60 over 3. Well, 60 over 3 is just 20. Okay, so see, that worked out pretty well. Now, 20 times negative 5/3 is going to be a negative 100/3. And when you do 35 minus 100/3, 35/3 minus 100/3, that's going to be negative. And then when you do this, that is 65/3. Okay? Cool. Now we plug back in our x's. Again, this is your remainder. Okay. When I plug my numbers back in, again, I'm going to start with an x to the 3rd. So that's a 4x to the 3rd. A 0x squared, so I'm not going to write it down. Minus 8x plus 20 minus 65 over 3 over x plus 5/3. Now look at how ugly this looks. Okay. So to clear this out, we multiply everything by 3 on the top and on the bottom. When you do that, the first part stays the same. The top, those 3's cancel out. That's just a 65 over the 3's cancel out here, but you still have that 3x plus 5. Now this part looks a lot like what you had to begin with. Okay? So a little tricky. Be sure you pay attention to these questions.